Alright, we're going to work on section 3.4, which is solving equations that have variables on both sides. So we need to make sure that we get those variables together, it doesn't matter what side they're on, so we can isolate that variable, because that's our goal all the time. So we need to move either the 8x or the 4x, and it really makes no difference. I'm just going to choose to add the 8x to both sides to get our x's together. Then we're going to have 7 equals 12x minus 17. We're going to have to add the 17 to both sides. 24 equals 12x. Divide by 12, and x is 2. Of course, you can plug that back into the original one to check and make sure you have the right answer. Okay, when we have grouping symbols, that means a distributive property. We're going to have to distribute that 1/4 into both sides. Wasn't like last time where we could just multiply it to the other side, because we have parentheses over there, so we're going to have to do it either way. So we're going to distribute on the right side. 1/4 of 16 is 4x. 1/4 of 60 is 15. Now we have x's on both sides, so we have to figure out which one to move. Generally, you want to move the smaller one. So if one is negative, you want to add it. If one is smaller, you want to subtract that one to the other side. So 5x minus 5 equals 15. We're now going to add the 5 to both sides. 5x equals 20. Divide both sides by 5. And x is 4. Okay, now these are all practice. We're going to go through all of them pretty quickly. Get the variables together. Divide both sides by 8, and m is 3. Okay, here I'm going to subtract the c. So we have 20 equals 3c minus 7. Add 7 to both sides, so we have 27 equals 3c. Divide both sides by 3, and c is 9. So like I mentioned, you probably want to add whichever one is smaller, so more negative. So if we're subtracting 3k from the left side, we're probably going to want to add the 3k to both sides. Subtract 17, and k is negative 8. Okay, we have to do our grouping symbols. So that's 6z minus 8. Subtract the 5z from both sides. So that's just z minus 8. Add the 8. Z is 6. Do our grouping symbols. I'm going to add the 4a to both sides. Add the 15. Divide both sides by 2. Or by 9, and a is 2. Okay, distribute that 2/3 in. Subtract 4y from both sides. So the left side gives us 4y minus 6. Add 6. Divide by 4. Y is 4. Real world problem. A car dealership sold 78 new cars and 67 used cars this year. The number of new cars sold has been increasing by 6 cars each year. The number of used cars by the dealership has been decreasing by 4 cars each year. If these trends continue, in how many years will the number of new cars sold be twice the number of used cars sold? Alright, so we're going to do a verbal one first. New cars sold this year plus the increase in new cars sold times the number of years. It wants to be twice the number of used cars sold. So it's twice the number of used cars sold this year, and it's going to look the exact same on the other side, only it's a decrease in the used cars sold times the number of years. And our question is the years, so that's what our variable is going to be on both sides. New cars sold this year was 78. Our increase is 6 times the number of years, which is x, equals 2 times the used car sold, which is 67, minus 4, because it's decreasing, or plus negative 4, either way. So we need to distribute that 2 into the parentheses on the right side. Which gives us 134 minus 8x. I want to get those x's on the same side, so we're going to add the 8x to the other side. Subtract 78. Divide by 14, and that's 4 years. Okay, so the last thing we're going to do in this section is identify the number of solutions of an equation. So that means that there could be times where you have either a no solution situation, you have infinite solutions, or you have just normally one solution like we have in a regular problem. So we're going to go through it and I'm going to show you the difference. The first one, we're going to distribute that 3x into both sides. So 3x equals 3x plus 12. We want to get our x's on the same side, so we subtract one of the 3x's. So we get 0 equals 12. Now, obviously, since that doesn't make sense, we know that this is a no solution situation. If we have 0 equals anything else but 0, that's no solution. On the b, we're going to distribute on the right side. Now, we have 2x plus 10 equals 2x plus 10. Now, when does that happen? This is always, that happens all the time. So this kind of problem is infinite solutions. C, we're going to distribute. Get the z's on the same side. We actually end up with 12 equals 27, which is not the case. So that's no solution. Okay, let's distribute on D. 6a plus 6 equals 6a plus 6. That's infinite. And E, we're not sure what that is yet, so we're going to get the w's on the same side. So we're going to subtract the 7w and subtract the 1. W is 0. Now, because W is 0, that doesn't mean it's no solution. That just means that our solution is 0. And that is the last section of our packet for sections 1 through 4.